Hello everybody. Yes, it is I. I am back. Um, and we're gonna go straight into math. This is what my channel will be focusing on now from here on out. So let's get started. First, let's talk about, I'm gonna jump straight into the middle of pre-algebra right now and dealing with polynomials. So let me go through this book here and find polynomials. Two minus x3 equals 2. Oh no, just this. Okay, so what do we got here? Polynomials always have terms. These are terms, and the term includes many times it includes the operator of the next term of the next symbol that is after the operator, and yeah, this term here is so this is a mononomial, and it's all polynomials and all nomials are centered around the variable. So you can think of it as the planet and the sun and everything around it is like orbiting that variable. It's everything else is dependent on it. So sometimes you'll find a coefficient, which is like a number before the variable. So it's this. So here, so you got the coefficient. Maybe then sometimes you might have the degree, and then maybe you'll have the operator symbol, which could be a negative or a positive. And yeah, so that's a term in a polynomial. Poly means just more than one or just many. Bi equals like 2, and then mono single is 1. So that's where you get all those nomials. And nomial is just the prefix, or no, like the suffix, I don't know, like that after, at the end of the word kind of thing. But so yeah, so it can also look like this. It can also include a fraction. That's a mononomial. And 0. So 0 is a mononomial, and so is any kind of single number, single term, or coefficient, which could basically equal like this. That's why it's considered a term, because it's like saying x is 0, because x to the x power of 0 is actually just 1, and then times 4 equals just 4. So that makes sense, right? I just explained why a single constant can actually equal a monomial, or can equal a nomial. So with that understanding, let me grab a more complex monomial. Okay, 6x 4 plus 3x 3 minus 1. With that understanding, nothing here is like independent. Everything is, you know, sometimes with an operator and arithmetic, you'll just have like, you'll have this as like the center, and then everything, this is the operator, and everything here is just a constant, like it's subject to the operator. This is the provides the movement, but here everything is it's unique to, it's like an individual basically. So there's no like space between in monomials or polynomials, but yeah. So polynomials, what do they, polynomials, what do they kind of represent? Okay, so their key factor, like what's unique to all polynomials, is the variable. They always have a variable, and when that applies to real world situations, when there's a variable included, there's an unknown, right? So you have an unknown, and then it's influenced by, you know, like it's uh, so it's influenced by its algorithm that it's in, its process that it's in. So what makes up the process is real world descriptions of things. Maybe, you know, like you know, n equals like k over r. So n could be like the number of I don't know, clothes that a dry cleaner does in one day, and then k or r is like maybe the rate, you know. Well, this would be more like the rate, but this could be like the ruined clothes, the number of ruined clothes that dry cleaner does, based on the amount of work that is the workload that is completed. So that's basically what that is. With this here, that's how it translates to this. You have your unknown, but then these coefficients and other like variables, sometimes not, represent real world processes, just translated into the construct which the variable enters. So this is, the variable is the point of entry for this process, matrix, process, construct, algorithmic time structure, and then it's the way out too. Now I just pointed something there, something pretty key, but the unknown is the way in and the unknown is the way out. It reveals itself. It actually undoes the whole, like, you know how you can undo the whole process with just by finding, you know, finding x, finding the unknown. You could sort of like reverse it. So that's kind of like a phenomenon we got, with variables, how like the unknown in, unknown out, uh, it unravels the whole process, the whole algorithmic time process. But yeah, I mean, you could do all kinds of things with polynomials. We have our basic, so arithmetic, arithmetic, it has our pluses or minuses, divide, our multiplications. So, and then you have your constants, I guess, or your real numbers. We have our constants and our real numbers in arithmetic, but you can think of arithmetic as kind of like a abstracted view abstracted view of a polynomial, right? So 4 could be like, this 2 minus, I don't know, 100x plus half. Like this is what it means to abstract something. It makes something something complex into something simpler, like the illusion of something simpler, kind of. Because once you start abstracting things, it gets kind of messy and complicated. But so arithmetic is kind of abstracted from, like, if you're having trouble with polynomials, then if you look at it like this, it might help you out. But so you can do all the same processes with arithmetic as with polynomials, right? I think that's what I was getting at there. And this apply, like, you'll find this abstraction, how things I mean, if you can understand abstraction, you're going to understand math a whole lot easier. That's your key to unraveling math, because then, like, you'll be able to see, like, complex things are nothing more than just, on the surface they're simple, but they look complex, within. But yeah, so we can do all that with polynomials. Y equals mx plus b. So this would be the slope of the line, right? This has to do with graphing, but it's also a what's the word? It's not an expression, but it's like a it could be solved because it has an equal sign, right? So when there's an equal sign, it breaks down to a single answer. Anyways, more on this next time. This is all I got for you guys. Till next time.